Hello, everybody. Welcome to the webinar today. Thank you very much for joining us. We're about to get started in a minute's time, but a couple of pieces of housekeeping. Today's session is going to be about 30 minutes of presentation, and then there'll be some question and answer time at the end of it, so it's slightly longer than our typical sessions. Please, if you've got any questions as we're going along, please type them into the question box as we're going, and we'll pick them up and try and answer as many of them as we can at the end of the session. Also, you should be able to see in the handout section that there is a full copy of the slides that we've put together for presentation for you today, and you can download them and keep them for yourself as part of the session. So thank you for joining. My name's Peter Brickell. I'm going to be talking to you today about the office of the future and how we think it needs some fresh thinking in the design. I'm a director with WSP. I've been in MEP specialism of engineering, the building services, for about 20 years now, focusing heavily on commercial building design, both in the UK but also globally around the world. I also head up our UK innovation team, which looks at the digital delivery of buildings and the interconnectivity of data, as well as our net zero carbon roadmap and how we're going to deliver buildings to meet the future tasks. So I'm going to get going now, and I'm going to present to you on our thoughts of what's needed for the fresh thinking. So to think about the future of the office, I felt it was important to look back at the past of the office to start with and think about what that history of the office is, because the office space has evolved hugely over the years and has been through many iterations of innovation through its time, and how that's impacted and how the office has changed to lead on to what we think is the next big changes, the next big steps the office is going to see, and how we need to think differently for it. So if we go back, way back into 1726, the sort of earliest recorded or believed office coming out of the UK particularly was the old Admiralty building, which was put together for the naval. And it was a very regal building, and it was very cellularized, and people had their own spaces. But if you think back to then, there wasn't even light, artificial light at that time. That didn't come in till much later. And that invention of the light bulb changed offices forevermore. They became spaces that could be used at all hours of the day. The working day started to get longer, and that creation that the working day could become longer started the realization that the office was a way of making money. It became a place for making money. Then came along the elevator, and we've seen the explosion of what the lift does to the design of office buildings. We're going taller and taller and taller with our buildings, which would never have been possible without the invention of the lift, and how that's meant that we're looking at these tall, giant buildings moving lots of people quickly. Come to the sort of 1911 time, and this commoditization of the office space, you started to see these office spaces that looked like the factory space. They're turning these factory spaces, they're rows of desks, stacking people in, trying to make money from them in the way that they can deliver work from an office space. And it's worth keeping that in mind for a picture in a couple of slides' time. There was a rebellion against this in the sort of 1960s, 1970s, of everybody wanting their own space and trying to create the flexibility of the office, the Herman Miller Action Office, where it was supposed to be a modular set of office furniture that enabled you to kind of get your own space but still be in the office and change, which unfortunately led to the cubicle farm that we know and love from history, and we've since moved away. Then came the technology revolution, the invention of email, the invention of everything that's going on, that led to the working day following us everywhere. There was no break from work. It was always with us. The discussions of a work-life balance started to be a hot topic in what we were doing. And in the kind of current day, we've moved back to those big, long desk under the guise of collaborative working. And that's a picture of my office, and it's quite scary how similar it is to a factory of 1911 for how we pack people in and how they're working and how we work going forward. Now, there's been these huge waves, whether it's been the light bulb or it's been the lifts or it's been the technology. There's been these huge waves coming in that change the face of the office and change how it's going to be treated and how we deliver our work from those offices going forward. And right now, we feel there's a perfect storm going on between the global pandemic situation that we've been in and the ever-increasing drive to meet our net zero carbon targets and create sustainable buildings. And this balance between what COVID's doing and creating people working from home and a dynamic office space and the need for this climate change and needing to drive efficiency into our buildings is creating what this future of the workspace is. So I think given everything we read in the press, and I'm not going to go into the social of the press, but I think with everything we're reading there, we see that this kind of office that we abandoned for 2 years during the pandemic is probably a thing of the past. And you see all sorts of stuff and all sorts of pictures about the future of flexible working that implies a workspace that is inviting and makes people want to come back to work and not stay at home, to collaborate and integrate rather than sit at a desk and punch out numbers, is potentially the future. And we see a lot of this going around in the discussions in the newspapers and how companies are addressing it, and we'll see it in our own workplaces. But what we probably don't realize in the background is that for those of us designing the detail and the engineering that enables these buildings, this changes everything for us. It changes the architecture of the building in terms of the types of spaces we're designing, the types of finishes we're using, and the types of environment we're creating for people to work on. But behind that, it changes the fundamental basis of how we design. How do people now enter the building? Everybody used to be at their desk by 9 o'clock in the morning, but now people are more flexible. They're coming in at different times of the day. So how does that affect the lift design? Do we need as many lifts? Do they need to move as quick? Does that change the core and the structure of the building? People are working more flexibly. They're not sat at desks with big screens and everything that goes with that. So the use of laptops and modern technology is changing the equipment gains and the way we deliver power. Because we've got more or less people in different areas, the space for the fresh air we need to do is different. We want different flexible spaces with environments, so we've got different lighting solutions. And all of this affects the cooling loads and ultimately the energy consumption of the buildings that we're designing to. So this little move about saying we want to just create more collaborative spaces that you think fit within the office space you're in, change the foundations of what we need to consider for designing the building. Then we add that to the net zero carbon situation and the drives we see globally to maintain global temperatures at a certain rate. And I'm not going to go into net zero as a whole in this presentation, but what we see from the results, and this is figures from the UK Green Building Council for the UK market, and this is similarly happening around the globe, is that 40% of our emissions, our carbon emissions in the UK, is made up by the built environment. So our buildings, what we're doing, how we're operating them, how we're using them, is using up a huge percentage of our UK carbon footprint. So if we as a world of economies want to try and achieve a net zero future, we've really got to address the buildings that we're in, and the office buildings are a significant part of that. And all across the globe, we're seeing people commit to this. This isn't just everybody saying we need to be lower carbon, because we've been saying that for years and years and years now. This is seeing an unprecedented sign up. There's lots of people, whether it's 2030, 2040 or 2050 in your country, in your area, everybody's signing up to this net zero. And we're seeing huge amounts of sign up for this, with all the biggest companies vowing to cut their carbon emissions and announcing it. There are thousands upon thousands of companies that have signed up to the Science Based Targets initiative to try and achieve this net zero. And they're all signing up to it. But do we really know what that means to our buildings and what it's going to hit with us? And the last impact that's coming from this, that's driving this element, is going to start hitting, whether we're developers or whether we're just part of the public that are designing this, there's an impact to the financial market that we're looking at with our buildings. It's always been the case in the past when new regulations come out for new levels of green targeting, that the first people that develop those buildings and can advertise that their buildings are more sustainable will see these increases in their rental premiums for their buildings. They get this kind of this green bonus to what their building is. But this is really a short-term boost to what they're doing for those most proactive, because as the market catches up and everybody's got a building like that, you don't have a unique selling point anymore. But it's being put out there in the press and in the news now. JLL have put a lot of stuff out of there for us that are talking about it, about these brown discounts. This fact that actually, with all these companies now signing up, committing publicly to achieving net zero, if the buildings aren't net zero, it costs more to upgrade them than move around. These buildings are going to just not be able to attach those premiums to it. They're going to have to invest. There's going to be big costs to people to invest to get them to net zero if we don't start thinking about it fast and retrofitting our buildings and designing our new buildings quickly. And this doesn't just hit the owners, the developers and the funders of the projects. If we look at economies like the UK economy, huge parts of our pension schemes are held up by investment in large commercial developments within our country. If the large commercial developments start to see a 30% discount on their rentals, the value of those portfolios that are used for the pensions that every one of us relies on start to lose money. This could be a serious financial issue to us and to our economy, as well as net zero, and how do we get people back to the office in a post-pandemic world. So realizing that all these items were coming and all these things were happening and all our clients were talking to us and asking us as a team, as a company, how are we going to help them with this? How are we going to help them design their buildings better? We said to ourselves, well, we're a large market-leading global consultancy that specialises in the design of buildings. Our buildings are good, we just design a bit better. We must already design the best buildings that are out there. So we went away and had a better look at some of our buildings. And we thought we need to compare our buildings to something. And this graph that you can see on the page at the moment is taken from the UK Green Building Council guidance for an office. And it's in line with the Neighbours UK rating. Anyone that's listening to this from Australia, this is all our stuff moving over to a Neighbours rating from the Australian Green Star setup. And we thought we'd have a look at this and look at the kind of ratings we need to be achieving for making a net zero building happen. And we thought we'd compare this to one of our buildings at the moment. This is the energy rating from one of our current top performing office buildings that we're designing at the moment. This is achieving the UK Part L requirements. It's meeting the London GLA planning guidance. It's 40% better than Part L. It's meeting all the current guidance and exceeding it, and designing to the best practice that is put in place to meet our regulations at the moment. And yes, these two graphs are at the same scale. You can see that if we want to achieve net zero, we need to more than halve the energy in the buildings we're doing at the moment. This struck a chord with us that this is a much bigger issue than we were giving it credit for. So we thought we've got to start looking at this in a lot more detail. We looked around at more information. This comes from the Better Buildings Partnership snapshot. And what this graph is showing you here is it is a range of about 200 buildings that have had their energy consumptions in real operation looked at to understand how much energy they're using, what their energy intensity is in their building. And each of the grey lines represents a building. And the bar along the bottom is in line with the UK Energy Performance Certificate system, which is much like your labels you see on your white goods with whether it's high performing or not. So we design buildings in line with our guidance, our EPCs, and what this is showing you here is that we have buildings that, to our current design guidance, could be rated as an E building that are outperforming buildings that are rated as an A building. This isn't new to some of us. This is known as the performance gap in our industry, but it shows how designing for energy efficiency in terms of our current building regulations don't work for the real operation of buildings. And the green lines in the middle show you where that kind of average is. It sits around the 200 kilowatt hours per meter squared. And our best building we were looking at was looking at about 160. So we are in the good half, but there's still such a long way to go. So we started to question everything. We went back to that building, we looked at those results and we thought, what's taking up the biggest amount? What's going on? And the first thing we noticed, the big obvious bar you can see in the middle, is that the energy consumed by the electricity to power our equipment in an office, our computers, our screens, our printers and stuff, and the electricity to power our lighting makes up the lion's share of the energy consumption in our buildings. Not the cooling systems, not the HVAC systems. This isn't a design issue now. This is a specification and operation issue for those using a building. You can see that it's up at 90 kilowatt hours per square meter, and we need to be trying to achieve 70 total for the whole building. And surely with modern technology and LED lighting, it should be less than this. So we did some more digging, and these profiles here are taken from the Neighbours UK guidance that is built, as I showed you, on some existing buildings and how buildings are operating and the data they've got, feeding off all the knowledge they've had from years of operating this system in Australia. And what you'll see from these profiles is the issue, they look sensible until you look at what hours they're operating. If you look at the weekend profile at the bottom of that page, 25% of our equipment load, so the load for our computers and our screens, operates all weekend when no one's in the building. And this is coming from real data. This is looking at real operation of buildings and how buildings are seen to operate to get these figures. We're using huge amounts of energy out of hours. We dug even deeper into this and took a closer look, and we broke that energy load down into the different hours of the day. And you can see these are the hours of the day that electricity is being used. So 40% of the electricity used for lighting and small power is used when no one's in the building. But even the energy that is used when it's in the building is far more than we can allow for what's in there to try and meet these targets. So performing some testing, we had a look at what would happen if we look to turn it off at the weekend. If we could control that, we could reduce the hours that it's being used. And just reducing the hours it's being used didn't work on its own. We had to reduce the criteria that we were designing to and the power allowances that we were doing. In the UK, the design of our office buildings is very heavily linked to the guidance that's produced by the British Council of Offices, and they give us direction on the kind of power consumption we should allow for in our designs, and the view of where that should be operating and what's going on. And what we found is that we need to not only look at the guidance that we're designing to and how the industry needs to change its guidance, we need to look at how people are using their buildings, how they're operating them, and how they're turning stuff off at night and where they're working with them, and the types of equipment. This starts to become, the office of the future does not become something the design team can look at on their own. It comes into procurement of IT services that tenants and users of the building will be looking to use. Now, this compounds itself back into our market of data. So if you remember a minute ago, I told you that 40% of the UK carbon emissions are made up of buildings. And what we've just talked about there is the criteria in how we're designing buildings. But when you look at the UK, and this again similar for around the world, if you look at the UK, 80%, it's predicted 80% of the buildings that we're going to have by 2050 when we want to be net zero are already built. They're already here to work with. So this isn't just a new build job. If we fix this in the new job, the new buildings that are coming, we're only going to address 1/5 of the amount we need to address in what we're doing. So we have a real problem with gathering this stuff, because if we're going to attack existing buildings and all these operators of buildings need to look at this and drive their energy down in collaboration with their tenants and how they're using their building, we have a real problem with data. We need to understand how a building's being used, where the data's going, where the power is being used, and how we're going to do it. And traditionally, that gets hit by problems with our engineering systems being very disconnected and the information not joining up. And quite a lot of people want to keep their cards close to their chest. They don't want to share this data that's out there. So we need, as an industry, to be breaking down these barriers. And there's ways we can do this. There are lots and lots of emerging technologies and strategies that can be developed around smart buildings that can gather this data, it can analyze it, it can help us understand the operation of these buildings and bring this stuff together. And in terms of sharing our data, as things like Neighbours UK grab more traction and potentially become legislation in the future, we will have to advertise what rating our buildings are. We will have to tell people where we're at. So that data will start to become apparent and we can start to tackle it. But it means change for all of us. The way we design the building, the technology we put for the building, the criteria we're setting, the way we're selling those buildings, all of these areas need to come together to think of the office building as a different environment for presenting the information that we're doing. We also need to consider it across its whole life cycle. I'm talking to you here very heavily about the operational carbon that we're talking about, but there's more to it. There's the whole life cycle of a building in what we're doing. And in one test of a big development that we were looking at, we made this one change looking at these power demands and what we were doing, and it brought the peak cooling capacity down by significant amounts. And when you start to bring that round to the whole life cycle of it, that one change, just changing the primary cooling plant selection, saved over 1,000 tons of embodied carbon from the building. Now, this is a big development, but those proportions happen across all the developments that are in there. These MEP systems, these large plant systems and everything that go with them have huge embodied carbon impacts as well. And more so than structure or facades, the engineering systems that go behind them have a life cycle cost because they get replaced. So the smaller they are, the less we replace, the less impact we have in the future. Then we thought, having looked at the operation of the building, we have to go back to the basics. So we've talked about changing the specification and changing the criteria of how people use the building. We need to look at the way we change and design buildings. And we questioned ourselves as to whether buildings like this were a thing of the past. We've We've designed a number of the buildings in this picture. We love designing these tall buildings, but they are all great big, huge glass buildings. If we've got to over half our energy consumption, can you design buildings like this, or are they a thing of the past? Now, I don't think any of us really know the answer to that. It's going to be a juggling act. But we did start to look at some of these impacts. Now, for those that don't understand the numbers, it's not important at that point. The numbers at the top of the page here are a high performing kind of current specification for a facade design. And what we did was we took that and we simply applied improvement factors at 10, 20, 30 and 40%. And we thought, we'll test this and see what it does and how much does it improve the energy consumption. So those percentages are percentages of the energy consumption we're improving. And we thought, actually, these are tiny numbers. So potentially we could look at keeping those buildings how they are. But when you then relate it back to the engineering systems, while they look like simple numbers in the kind of energy consumption area where it is, that's a 20% reduction in that peak cooling capacity. So again, we're back to this whole life cycle, this embodied carbon consideration. We also did we were looking at various buildings, and this is one of those buildings in that cluster of pictures I just showed you, and looking at it. And actually, do we need to think about our buildings differently? They're so uniform, they're glazed all the way up them, they're the same all the way round on a lot of stuff. But based on the shading and whether we're facing north or different orientations and stuff, do we need to stop our buildings looking so uniform? Do we need to think about each facade differently and design them differently and create what they'd look like differently? So we actually built an optimization engine that did a bit of testing here, and we let the computer try to give us the answer, try to tell us what would be this optimum facade for this building. And it's a very simple square building, so it's just north, south, east, west. And we had a look at that data to see what it said. And it looked at a number of situations, and it came up with this mix of lots of glazing on the south facade, but huge amounts of shading to block out direct sun. It allowed reasonable amounts of glazing on the eastern facade, but it really didn't like the western facade on this. And then obviously on the northern facade for the UK, lots of glass, no shading, let all the light in. But when you look at the results in this table on the right hand side, this compares what it's doing with daylighting. So we're looking at energy for heating and cooling systems versus the daylighting. And you can see how various improvements that the optimization engine made the building more energy efficient, but they didn't do much to the daylight autonomy in the space. It was still making a nice lit, daylit space. And that went all the way up to having a windowsill height. An awful lot of our buildings have no window sills. They are glazed floor to ceiling. But if you do the analysis, that bottom meter of a building's glass does nothing for the average daylighting on the floor, but it lets lots of solar light in. And putting that sill height in did nothing to the daylight. After that, properly reducing glazing ratios beyond that did affect it. So I think there's a balance. We believe there's a balance to it as a company, and through our analysis that there should be a balance to it. But are those things of the past? I would say I think there's a bigger consideration to be had, and things like sill heights and shading are going to become a much greater thing in the future for designing buildings. One of the last sections we looked at that point is to look at the engineering system. So we've looked at the brief, we've driven the brief down, we've understood how people are going to operate the building, we've got the people in the building to operate as efficiently as possible. We've passively designed it so that the least amount of energy consumption is being made from designing it. So then we need to look at the engineering systems. And from the UK and anywhere in the world that has similar temperate climates, the ultimate solution for us was to look at free cooling. If you look at our weather file, which is what I'm showing you here, 80% of the operational hours of an office, the air temperature outside is cold enough to do the cooling we need inside the building. And we don't typically do this at the moment. Some of that is stigma around opening windows. We sit there and sort of say, right, if we're going to free cool, we'll open the windows. But there's all sorts of problems from that. For anyone who's designed an office building, there's problems with single-sided ventilation not getting deep enough into our floor plans, or you get people at the window who are comfortable and people inside the floor plate who are uncomfortable, or vice versa, and windows opening and shutting and arguments, and it just becomes difficult. But not to mention the added cost and the loss of energy from air leakage, because these aren't tight facades in the winter. So it causes us problems. So we don't typically see this on our large office buildings anywhere in the world. Another reason for it, which has been where we've driven as a market, is we have been net area driven, getting net area up, value out of it. Every penny we can sweat from our office spaces has been massively important. And so that's driven us down minimum fresh air systems with all our heating and cooling distributed by pipework. The diagram on the left there shows you how 100 kilowatts of cooling in a pipe takes up an awful lot less space than 100 kilowatts delivered by an air system. And the diagrams on the right give you that kind of comparison, that if we take that minimum fresh air system out, we end up with much bigger ductwork. So just saying we're going to do fresh air, we're going to do it, isn't going to get us there. We as designers and engineers need to think of different solutions. We've at WSP have been looking at hybrid solutions that look at gaining connection to facades on floor on office spaces while maintaining minimum fresh air plant for the winter seasons, and looking at how we can get this free cooling optimized into the space so that you can still have a sealed facade, you can still have the air tightness, you can have the minimum fresh air space efficiencies, but you can still have the free cooling. And there'll be a number of solutions to this, and we as designers need to address this, but also we need developers and everyone who has signed up to these protocols to think of carbon over area a bit. None of these solutions are going to be ever quite as area efficient as the minimum area solutions we've been focusing on for the last sort of decade of designing offices buildings. But they have to remember that this loss in area, this small loss in area, is going to get more than covered if the predictions that are coming from the industry about this brown discount become true. So we need to look at these solutions and work together. As a little parting thought from this, as I said, I focused incredibly heavily on the operational carbon, and there is this the drive for these operational carbon things coming in, like neighbours, where our owners of buildings are going to become judged on the operational performance of our buildings. So we have to start to consider this, and we have to focus, and we can't just design a better building from an engineering point. We can't design the architecture and operate a building how we've always done before and the engineering solve it. It becomes a solution that everyone from developer to client to letting agent to operations and management to designers need to consider. While we're doing that, we need to consider the whole life cycle costing, and without all these people involved, without a holistic delivery of what we're doing from conception to construction, we're never going to tackle this office of the future that needs to address everything for everyone. So thank you very much for listening to me carry on at you for, I think, about that 30-minute period. It's time for any questions to come through, which I'm hoping you guys have typed.
Yes, thank you, Peter, for a fantastic presentation. We have some questions coming through, so thank you for those. Please log your questions in the question box. We'll have some time to read them now. And also you can download the PDF version of this presentation from the handout box on the dashboard. I will start with the first question. Considering the life cycle of a building in the UK, what is the contribution to carbon emission of construction versus use? Cement production is a major source of CO2.
Yes, so if you're going to look at the whole life cycle of a building and you look at that carbon analysis, for the upfront construction of a building that we're looking at the moment, the embodied carbon is by far the biggest contributor to a new build's carbon emissions. The engineering systems that drive the operation have a lifelong carbon. So over the life of a building, if it lasts longer, every year it's operating, that operational carbon becomes a bigger item of it. So it is an interesting balance. When we're designing a new building, we do really need to think about them. And that's where I was referring to the peak size of plant and bringing that embodied carbon down comes. But if we think about the whole life cycle of the building and where we're getting to and replacing MEP systems in the future and everything that's going on, while the concrete and the cement was done once and isn't moving, then we do very much need to get that operational design down as well, because it has a lasting impact. And with social economic problems like the rising cost of electricity and everything else, it's going to impact our clients on the long scale of operating their buildings. And the last part to that question to remember as well is, as I said, particularly in the UK, 80% of the buildings that we're trying to make net zero are already in operation. So this operational thing, how we're going to get back into the retrofit, is how we're going to deal with 80% of the current carbon emissions, as opposed to the embodied carbon that goes into the new build that makes up 20% of the market.
Thank you for this. Another question is, while employees working from home certainly decrease the energy efficiency, let me start from the beginning. While employees working from home certainly decrease the energy use of office buildings, how does it affect energy use of home? Taking the two together, are we sure that we're working from home reduces the energy, the use on the net?
So some of this comes back to that sort of data question. We don't really have the data, but we know from some of the buildings we've looked at and where we're at, and any of you that were some of the first people that trickled back into offices or popped in and out during the true lockdown times, you will have probably seen, as I saw in the offices I went into, that while we'd all gone home and we were all using our electricity at home and we were all doing it there, our office buildings never turned off. No one turned them off. If you ever walked around the city, you could still see lights on, the air conditioning was going, the ventilation was going. So actually, while people weren't in there to drive the air conditioning systems to a peak, they were still operating at a base level. So having all these office buildings operating at a base level and having all of us at home is not so efficient. If we leave the home, then we take that power and our homes are off and no one's there and no one's using them. And collating more people together in a single place to deliver energy efficiently, I think would ultimately drop our electricity consumption. Of course, there's bigger social things about transport and transport emissions and carbon emissions from that and the balance. We could get on to distributed economies and having more offices local and less commuting. I'm not the expert to talk about those things, but there's obviously a balance. But I think if we're all at home and the offices are still doing something and they're not switched off, it's not efficient. If we can turn our homes off and come to work, I think there's an efficiency to be gained there.
Thank you. I will take the last question. We have additional questions that will be answered directly later on. The last question is, after the experience of COVID-19, how does this affect our thinking on the importance of ventilation? Should we be designing better filtration, for instance? Filtration, yeah.
Okay, so there have been lots of reports about how to deal with COVID and a pandemic, a future pandemic in terms of the design of the ventilation systems. I know that CIBSE have produced technical papers, and my colleagues and other colleagues from around the industry have all inputted to them. And actually, what those articles have shown is actually, as an office space with the good ventilation designs we're doing at the moment, that actually from a ventilation point of view, they're actually quite good and quite well performing in terms of controlling the spread of something like COVID. That said, with looking at what we're doing at the moment and the concerns over that, obviously the solution is to think we want more. The best thing to do is to have more fresh air. As lockdown restrictions were lifted, we were told to go, we could meet people outside where it's fresher, there's more air, it's getting changed, and we're not using the same air. So again, this is another reason why WSP have been looking at these free cooling systems and ventilation systems, because if we get them right, every hour of the year, which makes up 80% of the operational hours in the year, we could have ventilation that is 100% coming from outside. We could have 4 times the amount of fresh air going through our offices, making them less stale, fresher, and more ventilated. So that kind of combination of getting the free cooling for net zero and addressing that ventilation is another reason why we brought the two together to try and tackle this future of the office.
Fantastic. Thank you so much, Peter, for your fantastic presentation. So we're at the end of our webinar session. Please feel free to follow up directly with Peter via the contact details shown on the screen. And I would like to thank all attendees for joining today. Thank you very much for your time, and we hope to see you in our future webinars. Thank you.
Thank you, everyone.